Okay, so we're looking at transforming exponential functions today. And all the assignment asks you is to identify the parameters, this a, h, and k in an exponential function. And if you just write them down, you'd get 100, but if those numbers don't mean anything to you, then you're not really getting anything out of the lesson. So what I want to focus on today instead is if you open up Desmos, okay, and you might need to pause it if you can't put both windows up side by side, but put in these top two lines, just the way they look. So one function I just called it g of x equals e to the x power. And you just have to type in the letter e, it'll make it all italics for you, that's okay. Okay, and then on the second line, and then this is the function that is listed on your assignment, is f of x equals a times b raised to the x minus h power plus k. Okay, so this top one, this is actually the parent function for all exponential functions. And I know you don't really know what e is at this point, but I'll tell you, it's just a number. It's 2.71. It's irrational. It's kind of like pi. It goes on forever and has practical applications in math that you learn about later on. But all you need to know is that f of x, g of x, whatever letter you put, equals e of x is the parent function for exponential functions. Okay, and then the second one, this one in red, this just lets us put in any values for a, h, and k, which are the parameters we're looking for in the assignment. We also get to put in b, which I don't know why that's not listed, but we added it. You don't have to put these ones in, because as soon as you type out the second line, you would have seen sliders for these bottom four. The only change we need to make is on b. So if you click down here where it says, and yours probably says -10 here, just click it. And we want to change this range from 0 to 10, because b cannot be negative. Okay? And then what we can do is we can either adjust it manually, or what I learned today is you can hit this little play button, and you can see what happens as we change the values. So we can see we change a. Big thing you notice, as soon as it's negative, it flips it over, just like with any other equations we've done. If this leading coefficient is negative, it flips it upside down. We can also see that if h is 0, and we'll mess with h later, that this value of a is always going to be the y-intercept. So you did this last year, if you remember, because you didn't deal with this h and k with exponential functions. It was only a times b to the x, right? So a was always that initial value, right, where you started out. So you see, as we increase the value, it just changes that y-intercept, and as soon as it becomes negative, it's still the y-intercept, but it flips the whole graph upside down. Okay, so let's put this back to 1. Okay, so what happens when we change b, the base of our exponent? So we can see, as we get this, so we make it larger, right? It gets steeper, yeah, and then as it gets smaller, and this happens kind of quick, right? You see it gets narrower, narrower. For a 1, it stops being exponential at all, right? Because 1 to any power is just 1. But then what happens? We have a fractional answer, and you see that it actually, instead of growing, now it's an exponential decay, where the values actually get smaller. And hopefully you noticed that yesterday, right? Anytime you had a fraction here, like all your values were like the opposite, where x was negative, you had higher numbers, and then as x got bigger, y actually decreased, right? So if b is a fraction, your graph is decreasing from left to right, or exponential decay. Okay, so I'm gonna put this back to 2.8. Right, so be sort of close to our parent function. And then h and k, hopefully, sound familiar, right? We've dealt with h and k. As that gets smaller, shifts to the left. As that gets bigger, shifts to the right. Nothing too fancy there. And then k, as you probably guessed, as that gets smaller, shifts the graph down. And as it gets bigger, it shifts the graph up. Okay? And there you go. That's what happens when we change any of our values in an exponential function, how it affects its graph. So then what you can do, if you really want to see what it looks like. So our example here, y equals 2 to the 1/4 x plus 2, so b would be 0.25. H would be, now be careful here, remember, same as always. Since our function is x minus h, when we see x plus 2, that means that the value of h is actually -2, right? So it's always the opposite of the sign you see in the equation is your value of h. And then k is nice and simple. Whatever you see for k, that's what you put. So if it says -3, k is -3. Okay? So we could say this is an example of exponential decay, right? It's been shifted to the left 2 units, and it's been shifted down 3 units. There you go. That's what happened. That was our change. You can do that for any of the questions you see today if you really want to see what the graph looks like. Like I said, you don't have to, because all we're really testing today is what is the value of a, h, and k, and then later on, what are those values, what do they mean in general for our function. Okay, so try them out, complete both assignments, won't kill you, and then let me know if you have any questions. Okay. Bye.